All right, what do you think? Why does a math teacher never talk about how many sig figs something has? Why is that? And that'll put a purpose to our lesson here. What do you think? Yes, Hayden.
Because their numbers don't have error.
That's right. None of their numbers have error. They don't use measured numbers, do they? They use the theoretical numbers. So anytime you're in a world where you measure things, that you're going to have think about this. Now, we talked about this, and this will be, I've already done this twice. I don't want to do it again, but does anybody have any trouble knowing how many sig figs are in something? We've done that twice. But now, here's something your math teacher won't do either. When you do calculations with measured numbers, you got to have there's another thing you got to be careful about. And how can you record the answer? Did we stop at number 6 yesterday? Is that what happened?
Yeah.
Okay. Let me, hang on here. Let me get my pen out. Who had number 6? Which 2 people had 6? Okay, ready? On number 6, you said the calculator gave you this number, right? Now, this is an addition problem, isn't it? So what's the rule? Tell me, do you remember the rule? When you add numbers, that's significant figure numbers, what do you have to round to? Ben, do you remember the...
The least number of guesses.
Okay, so go ahead. Tell me how many decimal places are in this guy.
2.
So that's 2, like that's a hundredths place, right? What about this one?
2.
2. And it doesn't really mean to the right of the decimal. It means this is hundredths place, and thousands. So what's the least number? Hundredths. Okay, so if you want to round to hundredths place, the 5 is in the hundredths place, isn't it? Does it go up or does it stay at 5?
Stay at 5.
How do you know?
Because the next one.
Right, because I look one more and it's not big enough, is it? So what's your final answer?
3.35.
All right, and centimeters. Yes, a centimeter plus a centimeter plus. All right, who are number 7? All right, tell me what the calculator gave you.
37.5.
What is it?
37.5.
Okay. Now, the calculator doesn't even know, what is a liter divided by a liter? I'll give you a clue. What's your math teacher say x divided by x is? Just 1, isn't it? Okay, what's liter divided by liter? So they're not going to have any units. This is a 1 problem. It has no units, okay? All right. Who wants to be the spokesperson here again? Sean, you want to do it? Am I going to leave that there, or am I going to round it? All right, what's the rule you're going to use?
I'm not sure.
Okay, what rule? It says if you divide or multiply, you have to round to what? Say it. The least number of significant figures, okay? All right, Makeda, how many sig, this is a tough one here, be careful. How many sig figs are in this number? I know I like your thinking. You're thinking, I can tell. Sean, you thinking? You guys had to talk about this. How many sig figs are in that number?
3.
How many?
3.
Is that what you thought? Did you think 3? All right. How many people think it's 3? Raise your hand. Oh. All right. So we know the 1 and the 5 are in, don't we? Now, what about that 0? Is that a trailing 0? Yes. Our trailing 0 is always significant. No, trailing zeros are only significant if what? If there happens to be a decimal. All right, so how many sig figs here, Sean? How many sig figs? 2, and how many here? Uh-oh. So you had to round to what? You had to round to 1. Oh, no. Well, there's your first sig fig right there. Now, either that 3 stays as a 3, or it jumps up by 1. What do you think is going to happen? Sean, do I ever look at the next number? If I want to round to 1 sig fig, do I ever look at the second one? Ever?
Yeah.
Yes, I do. I have to. Oh, I'm big. Oh. Okay, so what are you going to put, Sean? I'm going to see if Makeda agrees with you.
30.
How about 4? You think that's pretty good?
Yeah.
What do you think? You think 4? 4? 4? Really? So if you had $37.50 and I rounded off, I said you have about $4. Is that what you'd say? Huh? You think it rounds to 4? It rounds to 4, but where you put the 4? You put the 4 in the ones place? What were you rounding? What you weren't rounding to ones place. What were you rounding? You were on the tens place, weren't you? And so the tens place is a 4. But now you can't put 4, but you have to put a 0. Now here's the tough part. How many sig figs does that have? Only 1. That's what you had to do. You were supposed to round to 1. You did. But you can't say 37.5 rounds to 4, can you? It just means a 4 in that slot. And then you have to put a 0, no decimal. Don't put a decimal. That was the hardest one. I think you guys had one of the hardest ones. Okay? Who had number 8? Ooh, we run out? Okay. Let's everybody do number 8. And tell me what you got in the calculator. Who? Let's see. 8. I want to get this out of the way. I want to get these done so we can do something new today. Huh. I don't see it in here. Okay. So everybody put that in the calculator, and then we'll see what everybody gets. I thought I had all these answers. I thought I had the answers written down here. No, not there. Not there. Not there. It's down here. Not there either. What did I do with that? Oh, here it is. Yeah, it is. All right, number 8. Like when I did the calculator, I had 54.75, and this is going to be kilograms. Everybody right? All right. Go ahead and tell me what you would write here, because you're calculating with significant figures, measured numbers. So tell me what. Go ahead and write down. Everybody commit. Everybody commit to something. Okay, let's find out. When you add or subtract, you round to the least number of decimal places. This is the ones place. This is the hundreds place. So what am I going to round to? The ones place. Okay. Now, which number is in the ones place? No, that's in the tens place. Isn't the 4 in the ones place? Okay, not either that 4 stays there or it jumps up by 1. Ready? Oh. Okay, so what do you think? What are you going to write? What? 55, right? All right. Be honest. How many of you got that right? Okay. So if you missed it, it might have been because you weren't sure about the rule, or you weren't sure what's the least number of decimal places. Let's do number 9. Everybody do number 9 with the calculator. And then see if you can round it to the right number. It's like a mini quiz. It doesn't count. For those of you who don't have a calculator today, you need one. But I'll write down what... is the next number a 3 or a 2? Who has a calculator? Is it 1.72 or 1.7? 2? Is there a 2 there? Okay, I couldn't read my number. Okay. And then does it go 776 after that? All right, if you don't have a calculator, this is what the calculator would have said. Now, I want everybody to commit. I want everybody to commit to what they would round that to using measured numbers. And then put the correct unit afterwards. And it's okay if you make a mistake, but don't leave it blank. Don't leave it blank. You have to commit. Does everybody commit? All right, does everybody commit? All right, here we go. Well, the easiest part is what's a millimeter times a millimeter times a millimeter? A millimeter cubed, which that means it's volume. A millimeter to the third power is not a distance. It's a volume. It's a little cube, okay? Now, the rule for multiplying and dividing is the least number of significant figures. Okay, how many sig figs in this guy? Everybody. 4. How about this one?
3,
3. How about this one? Uh-oh.
3, 2.
How many?
Two.
There's only 2. There's no way that fits any, neither one of these fit any of my 3 rules. None of them. None of those are trailing zeros. They have to come after a sig fig, don't they? None of them come after a sig fig. So I have 4, 3, 2. Round to 2. There we go. Here's my first sig fig. There's a second one. Now either that 7 stays or it goes up by 1, right? Let's try it. Oh, you're not big enough. All right, so what's the answer? 1.7 cubic millimeters. Yes,
My calculator got a different answer.
I can't hear you. Say it again.
Or my calculator got a different answer.
Oh, you did? What, is this a 2?
No, it's 0.00.
Whoa, whoa, whoa. Did you multiply?
It's 0.00.
I had another class do it. They got 1.72776. You did not get
They
that?
did it wrong. They did it wrong.
Whoa. Whoa. What? Okay. Can you tell me what number it is?
0.
I just asked them. They took 0. What?
0.00. 17277.
172?
Yeah.
77?
6.
Wow, really?
Yeah.
Huh. Okay. All right. Let's change that then. Oh, I know what they did. They may have had their calculator in scientific notation mode and they had an E. They know what an E means in a calculator? Times 10 to the. If you see E minus 4, that means times 10 to the minus 4. Now, let's try it again. This is what the calculator said, but it's the same rule, but I'm glad you brought that up. Thanks, Ben. I still have to round it to 4, 3, 2 sig figs. Now, watch right here. Tell me if this is a sig fig. Is that or not? No. No. What's the first sig fig? Now I have to round to 2, don't I? So I look. Here's my second one. Is the 7 going to stay? Is the 7 or go up? Oh, no. No, not going up. Okay. All right. Thank you for catching that. Again, I asked somebody else what they got, and I just wrote it down. I didn't check it with my calculator. So, is everybody clear on that? This has 2 sig figs, doesn't it? All right, so the last one. If we get this right, I think everybody's going to be in good shape here. Do you already do this one? Aiden, you already done? You already done? Oh, what are you waiting for? That's the whole point. See, if you try it and get it wrong, then you learn something. If you try and get it right, you're going to reinforce something. If you don't try it, then you don't learn anything. So write down what the calculator got, and I'm gonna you check it because another student from another class gave me this number, and if it's not right, let me know. And I hate doing that. Okay. And by the way, what is a square meter divided by a meter? You said, how am I supposed to know that? Cause in math class, I'll bet you know this. What's x squared divided by x? What's x squared divided by x? Isn't it this? Isn't it x? What's square meters divided by meters? That's going to be meters. All right. Did everybody get this on the calculator? All right. Mallory, I don't call on you enough. I'm sorry. You're doing so well in class, but I should call on you more, okay? Can you tell me what rule I'm going to use here? Say it again. And how did you know that? Is this a division problem? So look up here and read this to me again. It says when multiplying, dividing, round to the least number of what? Okay, that's different than decimal place. So all right, how many sig figs are in this right here? Okay, sorry. How many significant figures are in here? 4? How about here? What's the least number?
4.
So we have to round to 4, don't we? 1, 2, 3, 4. Now, either that 7 stays as a 7 or it's going to go up by 1, right? What do you think? Oh, yeah, you're going up. Okay. So, now be careful. 8, 9, comma, 5. That 7 is going to be an 8, isn't it? But I can't just sit there like that. What? I'm missing something. What do I have to put here? I put another 0. So this has 4 sig figs. That's what I want. And then the answer is, that's in meters. What do you think? So you're pretty good at this? Are you pretty good at this? Yes.
So like end of the third wasn't that?
No, excellent question. Excellent question. Now, when something's in scientific notation, they're telling you how many sig figs in this part of the thing. Now, this is actually tells you where the decimal is. And so this actually tells you how many sig figs. That's a great question you had. I don't look at this in a scientific number to see if it's sig figs, okay? That's a very excellent, those are called critical questions. That's how you're a good learner. All right, you'll always be a good learner if you have those critical questions. What do you think? Ready to leave this? Ready? Yep. Okay. All right. So when you're doing your homework, you could probably do the homework now and do all the significant figure homeworks. You should be able to do all the scientific notation homework. Let's see. Okay. Now we're gonna go change course a little bit here. Here is something that is commonly measured in many science labs. And it's called temperature. Temperature is used for all kinds of experiments, all right? Next door, I know that Miss Founds, they're doing an experiment in their advanced biology, and they're going to have some beef liver, and they're going to let the beef liver juice react with hydrogen peroxide. And they're going to find out how many bubbles are produced, how much oxygen is produced, and then they're going to change it and put it into a warm water bath. So you're going to have room temperature. The reaction is going to take place at room temperature. Then they're going to bring it to another temperature, and then they're going to put it in an ice bath and see what happens to the do you know what enzymes are? You guys have biology, right? Remember enzymes? Enzymes that break down things. So anyway, the enzymes in liver would break down the hydrogen peroxide into water and oxygen gas. Well, anyway, they're doing that, and they're changing the temperature to see what happens, and there is an effect. There is an effect. All right, so let's take a look. Everybody in this country probably is very used to the Fahrenheit scale. Is that correct? Now, what's interesting is, without looking, how many things can you tell me about the Fahrenheit scale? How many numbers do you think the average high school student knows about the Fahrenheit scale? Raise your hand if you know one without looking. Yes?
The freezing point,
And what is it?
32.
Freezing point of water, right? Okay, I agree. I think almost all of you know that. What else? See, if you're not from this country and you think, oh, you guys use Fahrenheit but nobody else does, you must know a lot. But look, they don't. What do you know? And what now? What's that? That's also 32. So if I heat something, if I heat ice, it'll start melting at 32. But what if I cool water, it'll freeze at 32. That's the same temperature, isn't it? What else do we know? You're supposed to know a lot about the Fahrenheit scale. That's the one you use. How many of you know the boiling point of water in Fahrenheit? You know it? Really? What is it? 212. What made you memorize that? Just memorize it? Okay. Anybody else? Anything else you know? What's your body temperature? What's considered to be normal body temperature in Fahrenheit? It is amazing. They think everybody would know that, right? Everybody who knows the Fahrenheit scale, they would know this, wouldn't they? 98.6. And what's a comfortable room temperature in Fahrenheit? What? Oh no. What do you think? All right, so I made a little mistake on my drawing. It's supposed to be a 72 here. 77 is too hot. All right, so here we go. Here's what I think you should have already known. I think you should know that water freezes at 32 and melts at 32. I think you should know that water boils at 212. You say, well, now I know it. I think you should know that normal body temperature is 98.6. Even though some of you, your normal might be 98. Some of you, normal might be 98.2. It's possible. But this is what they think is most humans. And most people, around 72 is considered to be room temperature. What's absolute zero in Fahrenheit? I don't think anybody in this room knows that. Is that right? Now, that's cold for water, but you know what? Things can get much colder than ice. Much colder. All right? All right. Well, anyway, what we're going to do is we're going to try to understand that when they switched over to the metric system, they actually didn't want to use Fahrenheit. Matter of fact, very few people use the Fahrenheit scale anyway. And it was, guess who invented this thing? His name is Gabriel Fahrenheit. He actually had a last name called Fahrenheit. And I think he got famous because he used mercury. Does everybody know what mercury is? It's if you look on the periodic table, almost everything on here, anything that's black, means it's a solid at room temperature. You get that? And if it's blue, it's a liquid. And if it's red, it's a gas. And so there aren't too many blue things up there, are there? What are the only things that are liquids at room temperature? Bromine and Hg. What's that? Mercury. So if I showed you some mercury, it would be a liquid, wouldn't it? And it happens to be a metal. It's the only liquid metal at room temperature. So anyway, he made the first mercury thermometer, and it worked really well. And he was able to make many of them. And so I think the only reason Fahrenheit's still around it was he made good thermometers, and a lot of people got them. But then when they went to the metric system, they wanted to, they still use mercury, but they wanted to use a different scale. And they wanted to scale, remember the metric system, the whole idea was to make it easy so everybody would get rid of their measurement system and everybody use the same one, and they did. Well, this one, they weren't going to use that. So they wanted something simple. So what's freezing water in the Celsius scale? I think everybody should know this. Zero. Is that pretty easy? Is that easy to remember? And what is boiling water in the Celsius scale? That's easy too. I like that. You know what? They didn't pick 50. They had to use powers of 10, didn't they? They could have gone 0 to 10. But then I didn't give you much room to say what's going on between 0 and 10, right? So they could have gone 0 to 1,000. But you know what humans don't like? Humans don't like saying, hey, what's the temperature today? 653. They don't like that. Humans like numbers between 0 and 100. See? So they're pretty smart. Let's go 0 to 100. Now, what is the rest of the world? Everybody in the world except for you, they know what their body temperature is in Celsius. Who's from another country, or they've been in another country and they lived there for at least a couple of years? Anybody lived in another country for a couple of years? You did? Did that ever come up in conversation about what your body temperature is?
No, because I was younger. So.
Okay. All right. Did anybody live in another country for at least 2 years? And you were old enough to, okay. We're going to figure that out. I'm going to show you how to figure that out. And what if I go to Italy and I want to know what's a good room temperature? What are you going to say? So anyway, I'm going to show you how to do that. And I'll tell you about this other scale in a minute. So here's your book has 7.5 pages trying to teach you about how to do this. If you'll listen to me, I can be done in 20. In 20 minutes, I can teach you what's in 7.5 pages in your book. Okay? So everybody ready? All right. Your book is going to have something like this. It's an equation to change Fahrenheit. If you give you Fahrenheit, it'll change it into Celsius. See that? And then there's another one on another page that says, if you give me Celsius, I'll show you how to change it to Fahrenheit. And then there's another page, Celsius plus 273, you don't have to worry about that, equals Kelvin. So we're going to talk about these. Now, Your book actually says Fahrenheit minus 32 times 0.555. And you say, why didn't you teach 0.555? Because I'm going to show you that it's easier to remember by using this. Okay, 5.555 happens to be 5/9. And your book says 1.8 here. Do you know what 9 divided by 5 is? 1.8. So that's why your book uses that. But I think if you remember the 5/9 and 9/5, it'll work. Okay. So I want to show you something. And I remember when I first started teaching. Even back then, they wanted people in our country to be able to change Fahrenheit to Celsius. And I remember my first year teaching, it was even in the 7th grade. I was teaching 7th grade science at that time. That was like 46 years ago. And I had this on a nice little note card because I'm the teacher. I should know. And so I had a little note card in front of me, and I said, oh, here's how you change it. And I wrote that down, and then they would practice it. And then I had this written on a note card also. And then we didn't use it for most of the rest of the year. And then guess what happened next year? I had to go find out again. I hadn't memorized it, you see. And that's the second year I said, well, I am a science teacher. Probably I should memorize this. So how can I teach you to memorize this equation? All right? All right, is everybody ready? What I'm going to do, I'm going to teach you how to memorize this one. And then I'll tell you how this one is complete opposite, and then you know both of them. All right, here we go. Now, I made up a dumb song. As a matter of fact, it's kind of like a rap song. I was rapping before rappers were rapping, but I didn't know it was a rap song. I just thought it was a stupid song. Okay, and so what I'm going to do here is it's a very short song. It lasts about 8 seconds, but I have done it over 200 times in my life, more than that. And so I get a little tired of the song because I have to get motivated. So for you to motivate me, I need a little beat going. It's just a simple beat. Go. If you can help me out here, everybody, go ahead. If you get me motivated, I'll sing this song for you. Ready? And no, you got to be. Wait, it's got to be like together. See, it's in. Ready? And wait, you guys musical? Okay, ready? I'm not motivated yet. Oh, I got it. First thing you do, subtract 32, 5/9. Yeah. Okay, well, that's as long as it lasts. Okay, it's a very, very short song, probably a 5-second song. So let's see what I just did here. Besides making myself look foolish, that's okay. It's okay. The first thing you do. Subtract 32, 5/9. Yeah. Okay. So what we're going to do here is I'm going to show you that this actually works. And let's go here. What is freezing water in Fahrenheit? Okay, here we go. Ready? Put this in your calculator. 32 is Fahrenheit, right? 32 minus 32 is what? And what's 0 times 5/9? 0. Does it work? What is the freezing point of water in Celsius? It works. Let's try boiling water. Put this in here. 212 minus 32. Try that. All right. 212 minus 32. Has everybody got that? Now, do you know how to multiply by 5/9? Yes? I know your math teacher does that. Okay. Did everybody get it? Now, what'd you get? And is that correct? Then I know it works. So now we're ready to find out. The whole world knows their body temperature in Celsius except for you. All right, ready? Tell me what body temperature is around the whole world. If I go to Vietnam, what's your body temperature? They're going to tell me. I could go find a 7-year-old, 8-year-old probably. They can tell me.
37.
What is it?
37.
All right, let's see if everybody got that. Did everybody get 37? What do you think? I have a son. He's lived in Bangkok, Thailand for 13 years. I thought he was going to be there for a year. Anyway, he kind of carved a little life out for himself there, and I don't know. I'd love for him to come back, but anyway, the reason I'm telling you that story, we talk a lot, but he'll say, well, Man, this whole week, we just had like 15 days in a row above 40 degrees. And for you, that doesn't make sense because above 40 degrees, oh, it's kind of cold. But what is 40 degrees? And you don't have to put in a calculator. What is body temperature? 98.6? And that's 37? And he's having 40 degrees? What do you think? Oh, that's over 100? It's over 100, isn't it? I can estimate it. It's over 100. So when he tells me it's over 40 degrees for 2 weeks in a row, that's some hot. It's hot there a lot. I will say that. They have 2 seasons, hot and not quite as hot. It's always hot there. Okay. All right. So now, what is a comfortable room temperature? If it's 72 in Fahrenheit, and you go anywhere else in the world, and you want to know what a comfortable room temperature would be, what is it?
22.2.
Oh, you're fast. You're fast. Do you like math? Oh, really? Okay. You seem to be doing well. What'd you get? 3. You tired today? Can you put these in? So you put, what I want you to do is put 72 in here, right? And then subtract 32, then times 5 ninths. All right, you don't have a calculator. What'd you get? Hey, you already answered one, I know, but yet. What do you have?
22.
Say it again.
22.2 repeating.
Okay, so about 22, right? So if I go somewhere else in around the world, and I'm looking for around 22 Celsius, aren't I? That's a nice, comfortable room. This room is actually not as comfortable. It's actually colder than 72, isn't it? Is that right? It is. Okay, and so now, what I'd like to show you is that how do you learn the other one? Okay, let's see if we can memorize this one. And I don't have a song. I've had a student in the past who made a song, and I give him extra credit for it. But I don't actually need a song for the second one because here's what I know. Whatever you did here, do everything the opposite, and you'll have the other equation. Here I start with Fahrenheit, but here I start with what? Okay, here I added or subtracted first, but not here. I'm going to do what? Multiply. And here I use 5 ninths, and here I'm going to use 9/5. And here I subtracted 32, but here I'm going to, now I know both of them. If you just do everything the opposite. Now, we're going to test that. We're going to see if this equation works, okay? What are the 2 things you're absolutely sure about? Fahrenheit and Celsius. Give me some numbers. What, you know freezing water or not? All right, what's freezing water in Celsius? 0. Let's put this in an equation. 0 times 9/5. What's that going to be? 0. Add 32. Is that 32 Fahrenheit? All right, let's try another one. Let's do boiling water. Boiling water in Celsius is 100. Let's do 100 times 9/5. Uh-oh, that's my time here. What? And then you add 32. It works. Does it work? Okay. Let me double check my time here. 11:30. Okay, thank you. All right, are you okay with that? If you memorize that stupid song, then you'll know the other one too. And then the other one, I will show you, let me show you what happened here. People kind of like the Celsius scale. It was kind of nice numbers, and some things were colder than ice. They could make things colder than ice, even in a laboratory. And then they theoretically figured out what's the coldest temperature that anything can be that they believe ever. And on this scale, it came out to be negative 273 degrees. And it's called, what's that fancy name for the coldest temperature you think anything can be? Absolute zero. Now, so absolute zero on the Celsius scale was negative 273. Now, I want you to listen carefully, and I'll tell you why the Kelvin scale is used for all sciences and all engineering. Okay, and because you say, why do I need another scale? Everybody uses the Celsius scale around the world for temperatures and labs, but if you use a mathematical equation, you have to convert it to Kelvin. Now, why is that? So can everybody listen? I'll tell you why. I'll tell you what's wrong with the Fahrenheit and the Celsius scale. They have positive and negative numbers. if you are a math person, if you're a math person, I'm going to give you a question, okay? What do you think is twice as hot as 10 degrees Celsius? And because you've been in math class, you're going to say what? 20. Now watch what happens. That's not right, but for you think it's right. What's twice as hot as 0 Celsius? And your math brain says what? How can 0 be twice as hot as 0? Here's another one. You're not going to like it. What's twice as hot as negative 10 Celsius? And your math brain says what? Negative 20. That doesn't make sense. So when you have a scale that has positive and negative numbers, it won't make sense mathematically. So here's what they did. They said, I love the Celsius scale. I love the Celsius scale. But I don't like the negative numbers. So they went down here. What's the lowest it can be? Negative 273, right? So guess what? Celsius plus 273 became the Kelvin scale. And look right here. What's this plus 273? Oh, this scale, absolute 0 is what? It really is what? All right. I tell a joke and some people don't get it. I get to teach. You know what the coolest thing in science is? Absolute 0. And here's another one. I think the Kelvin scale is okay. I think absolute 0 on the Kelvin scale is okay. I mean, so anyway, all I want to know is that now, guess what? What's twice as hot as 5 kelvins? They're not even called degrees. They're called kelvins. What's twice as hot as 5 kelvins? 10 kelvins. Huh. See? Now watch this right here. What is an ice cube in the Kelvin scale? See, add 273 to Celsius. What is it? And I'm telling you, you might think an ice cube's cold. It's nothing compared to some of these other temperatures. You get that? Put your hand in ice. Put your hand in dry ice. Oh, no. Put your hand in ice. Put your hand in liquid nitrogen. No. No. Okay. Well, anyway, what is boiling water on the Celsius, the Kelvin scale? Celsius plus 273, 373. Now watch. How many degrees are there between freezing and boiling water on the Celsius scale? How many degrees are there between boiling and freezing water on the Celsius scale?
373.
No, on the Celsius scale. How many degrees difference? 100. And how many Kelvin difference is it? 100. You know what that means? That means a jump on the Celsius scale is the same size jump on the Kelvin scale. All right, I hope you have a nice weekend. You could probably do your homework questions now on your temperature scale ones, right? I think you could do, I would try to get at least maybe 40 homework questions done before next Monday if you could. All right, thank you very much. Have a nice weekend.
On Monday instead because like I'm really hungry and
Okay.
it's been like a long
I'll be after
day.
school here if you want, but that's all right. You want to wait till Monday?
Is that fine? Yeah.
Yeah, but when are you going to do it on Monday?
What?
Can you do it at lunchtime or not?
Yeah, I can do it. at
Okay,
lunchtime.
all right.
Okay.